Let me know once you are good to see my screen. It is okay?
Yeah.
Okay. So let's come here. This distributed model we already discussed, right? How this is going to work for the file, its chunks, and its a replica, its a distribution with the name node and data node, where it is working in a master slave architecture. Name node is the master, data node is the slave. Actual data is getting stored to the data node, and metadata is going to be stored and maintained by the name node, and with that metadata only name node do all the trackings and all, and getting uh, and it gets health status using heartbeat and checkpointing from the data node, and it makes sure that everything is fine. At any case, if it is not receiving 10 continuous heartbeat, that means it is not receiving the checkpoints, then it considers that okay, this data node is down or failed. In that case, this again maintain the copy of the nodes data, whatever is available to that node, it will try to maintain that with another node to make sure that everything is in healthy condition. Then we have one passive name node, we can say a secondary name node, that is for the copy of or high availability, you can say data security for the name node. It is making sure that okay, data is high available for name node as well. If in at any condition, if name node is down, then all the metadata details checkpointing is shared between both. So passive name node is also having the same detail, same data. If name node is down, then passive name node can take place of name node, and your cluster will not have any impact. So this is how your distribution model is running for the Hadoop. And this model is going to work for any architecture, not only for Hadoop. If you go for cloud, in cloud also, you are going to create the server for your job. Here only difference is in the on-premise, your server is, your cluster is already pre-built. It is in advance, it is like you have 10 node cluster or 20 node cluster, and you are going to work with that. Investment is done in advance. In cloud, you do not have any pre-built cluster. Let's say you are going to develop a job, you know that I am going to process 10 GB of data and I need maximum 4 node cluster. Then for that particular job, you are going to create 4 node cluster as per your requirement. Again, you have another project, you are getting that okay, I need to process 1 TB of data this time and I need 10 node cluster. So you can create 10 node cluster for that particular job. So that is cloud is something, a platform which is offering the service as a ready-made service. As per a requirement, you get it. If you don't want, just till that close your means once your job and all is done, then your cluster can be off. So these are the things. But if you think about the architecture and all how backend it is working, then the model is same. There also, if you are choosing 10 node cluster, then it is working in the same way. How it is going to maintain the copy, high availability, replica, and all. So concept will be same. Either you are going to create a cluster, uh, means working with the cluster in on-premise or working with the cluster in the cloud side. Here, the different main difference is in on-premise, as I said, your this is advanced investment. Your cluster is already ready. You are just going to use. In cloud side, that is not because of cost and all. Unnecessarily, if you have the cluster, it is going to cost you. So we take the cluster and all as per requirement at the runtime. Okay, now I am going to work. I need a cluster. Let's create one. I have another job. I need 2 node cluster. Let's create that. So that's how we are going to use that. But model is same. So here we were right. So this is Hadoop server roles. You can say this is data processing. This is distributed data storage. Distributed data storage, it is happening with HDFS, where we have name node and secondary name node, and processing how it will happen. So for processing, this is taking map reduce. where you have job tracker, you have task tracker, and this task tracker is associated with your data nodes, worker nodes, and accordingly, this is working. Okay, yesterday we had said in the latest version name is changed, but concept is same. Then this is your Hadoop cluster. Now this is having rack concept, rack awareness. If you see here we have data node 1, 2. So let's say what happened. Let's assume that you have 100 node cluster. So horizontally you will see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. In that case, if data has to come, let's say, and for one of the file, one copy is over data node 1 and one copy is over data node 100. If they have to communicate, then there will be network, and from network side there will be latency, right? Because it's horizontal and it has to communicate from 1 to 100. In between, 99s are there. And if they are in the rack, then there can be, means the network congestion can be better. So here it is having rack concept. Rack concept means this is one rack. So let's say you have 10 racks. If you have 100 node cluster, your 10 data nodes can be inside one rack. Okay, now this has been bit optimized because they are with the racking. Now what happens? Uh, so, okay, so let's say here you can see NameNode, job tracker, secondary NameNode means they are also deployed in the same. They are also running over the one of the machine, right? So assume that they are running with the this machine. Now, let's say that you are having 1 GBF file, and that 1 GBF file is stored with the three replica, three parts and three replica. One part is here, one part is here, and one part is here. Or maybe one part is over data node 1 and one part is over data node 2. In that case, if this has to communicate with data node, same copy is available here also and same copy is available here also. For the replica I am talking about. Okay. If it has to communicate, which copy it will prefer? The copy which is available in the same rack, that will be having faster communication. The copy which is in the different track, that will be having some latency. So in that case, it always prefer the data parts, replica, whatever, which is within the same rack. That will be more faster for the communication. So this supports in faster communication between the data. Means this copy to that copy and replica and all. Okay. So, and again, it makes sure that as you asked, what if all three gets deleted, all three replica is missing. In that case, what will happen? So here, as I said previously, that if it is having three replica, it always maintains that two replica can be over the same data node, but at least one replica will be over different data node. So let's say two replica is with this data node 1. Second replica can be data node 2, but in the same rack, it will again avoid. It will never be on the same rack. If three replica and it is in the racking concept, always it will be in the rack. Then two replica can be either over the same data node or multiple data node and in the same rack. But third replica will always be in the another rack, maybe over any data node. Because maybe the entire rack can fail. The entire rack is having here you can see 1, 2, 3, 4 data nodes are there. What if this entire rack is down? Then all these four data node will down. In that case, how it will take care of that? So name node is having all the details and all. Even this here in this condition, name node will also down if rack is down. Then secondary name node is there that can be up, that can play the role of name node, and it is having all the metadata details and all. It knows that rack one had what kind of data, which file parts were there, which applications were available over which data node. So name node, secondary name node will play the role of name node and it will again take care of. It will recover the data from its replica. So because of that condition in replica, it will always try to maintain that one replica is always over the same racks data node, not in the same racks. Sorry, different racks data node and not in the same racks data node. Getting the point? So if we see the typical workflow for this, then loading the data into the cluster. Whenever we try to load the data, what is that? That is HDFS, right? Then we analyze the data, means you are doing something with the data. That is MapReduce. Then finally, once we do our means we completed our processing, then we are going to store the result. That is our HDFS writes again and read the result from the cluster. Then that is HDFS reads. You can do select start from or you can do direct file read. It can be. So you are having HDFS read, HDFS write, and MapReduce. So it is having very simple command read, write, and process the data. Like here, just a simple scenario. How many times did our customer type the word refund into the email sent to the customer service? This is just analysis. If you have to do this, then of course you are going to write a logic, right? That I read the file or read the, let's say they are having the incident. This is talking about the email. Then capture the data from each of the email. Then search for the refund keyword and aggregate by each of the email. That in each email how many time or the entire email means globally how many times a refund is occurring. They are requesting for the refund and all. So in this condition, what you will be doing? What will be your idea here? If you have to do the same work, how many times did our customer types the word refund into email sent to the customer service? You are going to collect all the data. Maybe you can have one email or 1,000 emails from the different customer. As you have to do the analysis, then you are going to get all the data together, and then you will be writing the same data to HDFS. Once it is done, then you will be applying your logic. Then finally you are going to write the output again to the HDFS location, and finally you will be doing the read operation. Okay. Then we have writing to HDFS. How it is writing? This is your client. This is your data node. Let's assume that you are having the data node 1. This is 5, 2, 3 are in the between. You can just assume this is 6. This is data node number n. Now, as per client, I wanted to write blocks of A, B, C of file.txt. You have a file.txt and you have to write that and then you have to process that. Then file.txt got divided into block 1, block 2 and block 3 because maybe it is more than 128 MB in the size. So if more than 128 MB, then for first 128 MB one block, for second 128 MB second block, and for the remaining data which is less than 128 MB third block. So it is getting total third block. Then you have client. Client is trying to submit. This is the data. Then request goes to NameNode. Then NameNode has all the information because NameNode is communicating directly with the data node with the interval. Then it knows that okay, where the space is available and where there is no space, where it can be. So it knows it is saying okay, you can place this blocks to data node 1, 5, and 6. Then these blocks will get placed to data node 1, 5, and 6. Now next replication will happen with the different or same data nodes. Then client consults name node. Client writes a block directly to one of the data node and data node replicates a block. So client will write the data first block only. This is not going to write the replica. But replica will happen by the data node. Data node once as soon as data node is receiving the block, it will maintain the replicas. Cycle repeats for the next block. Same will happen for the remaining parts as well. Okay, and here you have this can be configured with the DFS replication parameter in the HDFS-site.xml. Everything, each and everything I will say. Either you are talking about your Hadoop or you are talking about the cloud side. It is configurable. Okay, configurable in the sense they have some parameters which is working for you, but they have made it flexible that you can add, you can remove, you can modify as per your requirement. That can be. So here in HDFS-site.xml, let's say by default 3 replica, you can change that. Then it is having, let's say, checkpointing. It is communicating name node and data node communication is happening after each 3 seconds. You can change that if you want to change the heartbeat. It is configurable. For 30, 10 cycles, this is waiting for the checkpointing, and how frequently name node and active and passive name nodes are getting communicated and all. These all are things is maintained by different configuration files that can be. But again, as we are going for the developer points of view, right? So this is not our task. We are not going to care about that. Why we need to take care that how many replications are happening and how many either my node is healthy or not, my cluster is healthy or not. That is not my job. That is admin team job. So let them take care. We are as a developer, we are thinking about only how I will submit my job, how I will process my job, how I can optimize my job, how I can do smooth read and write. That's it. So we are not going to focus on that much. And anyways, in the real time, as of now, you should know how to do, but in the real time, you will not have access as well. You will not you will not be authorized for making all these changes. Okay. Then here is the concept of Hadoop rack awareness. Why? So let's say that you are having 3 racks where you have a file. Here you can see rack 1 is having data node 1, 2, 3, and rack 5 is having 5, 6, 7. And again you have rack 9. This is also having the data. So metadata, name node also always maintain the metadata. Here it is saying, okay, this is file.txt, block A. Block A is on data node 1, 5, and 6. So you see here block A. A is with data node 1 also, A is with 5 also, A is with 6 also. Means a 3 replica. Then it is saying block B. Block B is available with 7, 1, and 2. So block B is 7, 1. Sorry, this is 1, 2, and 7. This is the 7. And block C, data node 5, then 8, and then 9. The 8 is here. So in that case, this rack got down. This you can see this cross symbol. In that case, what will happen? This will recover the data because A is available here also and here also. Anyways, for A, there is nothing down. All 3 replica is available. For C, one replica is here, but 2 replica were with this data node. In that case, data is not, we are not going to lose the data because this this is at least 1 replica is available with this data node 5 with this rack. Then it will again take the backup from this. It will make this master copy. It will again maintain the 2 more replica, and everything will be fine. There is no impact. For A, anyways it is fine. For B, 2 replica is there, 1 replica will be down because this rack is down. In that case, again, it will maintain 1 replica for this B as well. So like that, this rack awareness is working. So this will work with never lose all the data if entire rack fails, and keep bulky flows in rack when possible, and assumption that in rack is higher bandwidth, lower latency buffer the communication. Let's say A needs to communicate with B. B is available here also. B is available here also. If it has to communicate, this B this B will having low latency, right? If it is communicating to this one, this will be if you compare this latency to that latency, this will be slower. This will be faster. A has to communicate with C. Then A and C. Here also A, here also A. C is also there. If this A is communicating with this C, this may having some latency. A is available here also. Anyways, this will be happening only if this is the master copy because primarily what works with the master copy of a replica only. Let's assume this is the master copy. Then this is going to communicate with this C block. but this will not prefer to another rack. Which is the nearest, either in the same rack or in the different rack, that will be preferable. And which is the nearest one that will be having higher bandwidth and low latency. So it supports in faster processing as well, faster read and write, faster processing. Okay. Then this is for HDFS writes. Here let's assume it is having the request for I want to write file.txt block A. Then you are having block A, B, C in the same way. This is the same file example. Then client is having the request for write. This is the name node. Name node is having all the details, all the metadata details. Then it is guiding. Okay, you can write to 156. There is the availability, memory is available. Then client is trying to write. This is data node 1, this is data node 5, this is data node 6. Okay, then do write. It is writing that. So name node picks two nodes in the same rack and one node in the different rack. Data protection locality by data protection and locality by MR. So name node, whenever request is coming, then itself name node is deciding that okay, I will I am giving three nodes detail that okay, you can place these blocks to 1, 5 and 6, but that time only it is considering that one data node, whatever I am suggesting, should be associated with different tracks. All three should not be in the same rack. So that name node is taken care. Okay. Then you have this pipeline write. Pipeline write is something, if you see here, oh yeah, right, like here you see the client is ready to load file.txt into the cluster and it breaks up into the blocks, starting with block A. Then client consults the name node that it's want to write the file and getting the permission from the name node with all the details that where it has to write. Then name node used its rack awareness data to influence the decision, and the key rule for the every block of data, two copies will exist in one rack and another copy in the different rack. And accordingly, this is following all the things. Now here for the pipeline, right, again with the same example, you are having block A, block B and block C. Client is requesting for write the file. Name node is giving all the details according to the metadata. Then it is guiding for data node 1, 5 and 6 is having availability. You can write, okay, block A is getting placed one copy here, two copy in the same rack. Then data node 1 and 2 pass data along as it's received. And this is for connection TCP. Maybe you people are aware about this. Anyone is aware? Connection and all? No?
No, no.
No.
Okay, no issue. We will get it in detail in the later sessions whenever you are working in the real time. This is related to the connectivity, connections and all. Where we are here also, okay, file itself got closed. Let me open that. I believe that you people have access for these files. Okay, so here also I have mentioned that it picks the first data node in the first list of block A, opens a TCP 510. This is the detail connection and says, hey, get ready for the receiving block. So this is related to connectivity. Okay, then you have pipeline right again, and then you have multi-block replication pipeline. For multi-block replication pipeline, this is file.txt where you have A, B, C, and the client is requesting for write. This is for 1 terabyte file. 1 terabyte file is going to replicate with 3 replica, then storage will be 3 terabyte, right? This will be replicating 3 times by default. Then storage capacity should be available with 3 terabyte. Then 3 terabyte network traffic also will increase because anyways processing will be happening with the main copy only, which is 1 terabyte. But this is going to maintain the entire three means that with 3 replica. So everything will be maintained for that as well. So again, this is block A, block A, block A accordingly as we see in the previous one. Block A and block B is block B and block C. All are stored. Then here you can see about the rack. This is the 1, 4 and 5 and accordingly multi-block replication pipeline is happening like it is coming with okay this is here and again this is going to one copy here and one copy here like that this is going to maintain all the replicas and all. So here you can see Hadoop uses a lot of network bandwidth and storage. We are typically dealing with very big files, terabytes in size. It can be terabytes, petabytes, zettabytes. As of now, every day size is growing day by day. And maybe mm, in 2024 and 25, we are discussing about terabyte and petabyte. Maybe after 2 years or 4 years, we will be uh, assuming that okay, this is very small data set, and we will be having some new intro for the data units and all. It can be because how data is growing, there can be something new as well, some new units we can't say, right? So then we have if you have 1 terabyte of file, then it will consume 3 terabyte of network traffic to successfully load the file and 3 terabyte disk space to hold the file because it is having the replica. Here, if you see, as the subsequent blocks of file.txt are written, the initial node in the pipeline will vary for each block, spreading around a hotspot in the rack and cross rack traffic for the replication because it has to maintain replication also. If you see how it is working, this block B is getting here. Okay, then from here it is making one replica here, right? So this is getting right here, block A. Then again, this is making one replica here as well. So once actual block is getting stored, then DataNode is maintaining the replica as well. So this is what. Then again, client writes a span to the HDFS cluster where you are having the client. Again, as we discussed, we have multiple racks and data nodes are placed within the racks. There are a number of rack and each rack is having some data node. Once we are trying to write, this is maintaining that okay, this data should go to this data node and this data should go to this data node. And always it is maintaining that in any case, all three replicas should not be to the same rack. At least one replica should be with the different rack. So it in any case, if that rack is down, then nothing will be lost. But here it is saying that let's say it is trying to write, then block size, file size. Based upon this, everything is happening, and more blocks equal to wider spread. Okay, less blocks, it will be narrow spread. Then you have name node. As of now, you understand about name node, right? I am assuming that yes. If no, then please stop me and we can discuss about that. This is the name node. This is our this is the part of cluster and this is master. We are having multiple slave nodes and they are trying to communicate. Name node is maintaining the metadata. Okay, I have data node 1, 2, 3. And 1, 2, 3 is having the details for A and C. Again, A and C means blocks. And file system, this is the file.txt, and that is having the part A and C. Okay, then I have block A and C. Data node is giving the detail. Then it is taking all the detail. And this is also saying, okay, I am alive. Because they are sending the heartbeat and based upon the heartbeat NameNode is considering that this is working fine or not. Then data node sends a heartbeat. Okay. Every 10th heartbeat is a block report. Means one heartbeat, 3 seconds, again one heartbeat. Then suppose any data node is sending the heartbeat and data name node is not receiving. It will wait for to consider that it is not alive. It will be going for one block report, because block report in the sense in each 3 seconds heartbeat, this is not collecting the metadata. It is collecting the metadata, means a block report for each 10th heartbeat, means after 30 seconds it is collecting the latest metadata detail and it is updating its namespace. So for every 10th heartbeat is a block report, and name node builds metadata from block report only. It will be keep on updating according to the latest block report. Okay. Then we have the name. Okay. So this is okay, right? Here it is saying for data node sends heartbeat, and every 10th heartbeat is a block report. Based upon heartbeat only, it makes sure that data node is live, and based upon the block report means each 10th heartbeat report, it maintains and updates the metadata, and the name node builds metadata from the block report, and TCP is for every 3 seconds, that is the heartbeat connectivity. And if name node is down, HDFS also will be down. But to make sure we are having passive name node, that will take care. Okay. So then we are having a replica. I believe that you are good with this concept now. Like this is the name node, this is the data nodes, and they are having the replica. If anything is missing, let's say this data node itself is down. If this is down, then this is going to get the report. This is saying, okay, this replica is missing. Then copy block A and C to data node 8, because 8 is having some space and all. Okay, then make one copy here. So in that case, whatever was killed or missed or unavailable from here, it will be make means this will make a backup to the different data node. So missing heartbeats signify missing heartbeats signify lost nodes, and the name node consults metadata, finds affected data. What is the effect? And based upon the result, it will maintain. Then name node consult track awareness script as well. It is also making sure that all are not sitting to the same rack. And name node tells data node to re-replicate. It will say, okay, this is down and this is lost, or this block for these blocks, this is under replica. So make one more copy to the different node. So that will get maintained. Accordingly, you have secondary name node. This secondary name node and name node have communication with each other, where for any of the data, it is saying it's been an hour, give me your metadata. This is configurable. Either this is 1 hour or half an hour, or you want for each 15 minutes, you can. Means admin can. So based upon that time configuration, both will communicate and there will be data share. So not a hot standby for the name node, connected to the name node every hour, housekeeping backup of name node metadata, and saved metadata can rebuild a failed name node. If name node failed, then the secondary name node is having all the data. This will make sure that cluster is up and nothing is uh, in a condition of loss. Then whenever you are trying to read and write the file, then also it maintains the same, where as data is available with the blocks and racks over the data nodes, then according to the name node instructions and metadata details, client receives data node list for each of the block. Because name node is going to provide, okay, this data is available here and this data is available here. Client picks first data node for each block, and the client reads block sequentially. Okay, because you are having, let's say you are having 10 blocks of the same file, Then finally, when you are trying to read, you need to read all the blocks, right? Then only your output can be complete. Otherwise, what will happen? Let's say one block is having a Delhi data and one block is having Mumbai data. You are going to, if all the blocks are not read, then maybe you read one city's data and another cities will be missed. So it needs to read all the blocks. So once this is receiving the data node list for each of the block, that this block is available to this node and this block is available to this node, then client will pick first data node for each of the block wherever it is, and then it will be reading all the blocks in the sequence, so your output will be complete. Like that, it is a data node reading files from the HDFS, where NameNode provides rack local nodes first. Local nodes, because you already know, if they are having with the local nodes and with the same rack, then bandwidth and low latency will also be available there. That will be working perfectly, and leverage in rack bandwidth, single hop and all. Then it is having data processing. Once the storage part is done, then this is having processing part, where it is having map and it is having reduce. So as we see the example of how many times word refund is appearing in the file, right? So for this requirement is to count. Then there is job tracker. Now you can see job tracker is taking place of name node master. Master in the sense this is master for processing, not for the storage. This is associated with name node only. Here is the name node, here is the job tracker. And then job tracker is going to control the processing part, because name node is controlling the storage part with HDFS about the blocks, about the racks, about the file details and its replica, missing replica, whatever has to maintain and all. But for processing part, there is the master for the same, and that is going to take care. Here it is going to initiate with the map task. Okay, map task 1, 2, 3. That is with the different data node, because where the data is stored at the same place, data will be processed also, right? So map task done. Okay, then this is saying okay, in this block refund equal to 3. Refund word was 3 times. In this block, there was no refund keyword, so it is 0. In this block, refund keyword was 11. So total count will be 11 plus 3, 14, because this is 0. So that will be final output, and 11 plus 3 equal to 14 will happen in the reducer phase. Map phase means only uh, output for the single block. Means one input, one output. So this is the one input, and for one input it gave one output. This is the one input, this gave one output. Reducer is going to aggregate the entire output and making the final output. So again these things will be moving to reducer side, and that will be 11 plus 3 equal to 14. So map, run this computation on your local data, and job tracker delivers Java code to nodes with the local data. That this is the code, this is the logic, this is the transformation, whatever you want to do, and this is what we are achieving to get your target. What is your target? Accordingly, your map task will run, and then your reducer phase will be running out. So here you can see uh, the parallel processing framework includes with Hadoop is called MapReduce, named after two important steps in the model. One is map, one is reduce. First map runs, it creates the intermediate output, and that intermediate output becomes input for the reducer phase, and then finally reduce will take, it will aggregate according to your requirement, according to your logic, and it will deliver the final output. Here again, in the same way how name node and data node were working, you can see this is the job tracker master. Then I need block A, no map task left. How tasks are getting processed internally. So you have different blocks. All different blocks are running with the map job and reduce job. So how many jobs are running? Maybe someone will be completing at the first. Maybe someone will be having some delay, some blockers. It can be maybe based upon the volumes also, this will be impacting. So this is going to process. Okay, this is the A, and this is I need block A. The block A is available here. So this is going to be available for each and everyone. So drop job tracker tries to select a node in the same rack as data. Wherever the data is, this will try to first pick up the same and the name node rack awareness. Okay. Then you can see this data processing reduce as we see in the last one. Map page is done. Once a map page is done, then your reducer phase will get started. And for reducer phase, map task 1 said that I am having 3. This was having 0 and this was having 11. 11 plus 3. This all is moving to reducer phase and reducer phase is getting final output and that final output is getting right as the result.txt and refund equal to 14. This 14 can be accessed by the client. Client means we, whoever is requesting, right? So for that request, this can be delivered. So reduce, run the computation across map result. And map task sends output data to reducer over the network and reduce task data output written to read from HDFS. Here one thing you have to take optimization. Optimization matters a lot in any of the job. Let's say you are having 1 GB of file and you have 10 GB resources available. This is not going to impact you. Your job will be completed within minutes, seconds and all. But what if your data is having terabytes and petabytes of volume? Then it will be impacting the processing and all. And whenever reducer is coming, then reducer means what? Data shuffle, data movement. Because these output were associated with different node, right? Now when reducer is getting called, all data is moving from this node to this one, right? This is available to this node, this is available to this node, all are moving. Data movement is happening. This is called shuffling. Okay, shuffling means data is moving from one place to another place. So in any of the job, how much shuffling is there, that much latency will be there in the job. It will be taking lots of time. Now, whenever you are applying the logics, transformations and all, you can always make sure that if we have any alternative, then do something that we can achieve our output model also, whatever we are looking for the same logic. And if we can reduce the data movement, if possible. Of course, we can't do always because it is the requirement. Data has to move, data has to shuffle. But if we have some option that can reduce, if not 100%, at least 1% also, 10% also, that is going to benefit in the processing time and all. So you can take up that. You can think about that. That is always a consideration. Okay, because optimization and slow processing and all this is a big concern because we are not going to deal with the small data sets as a data engineer or in data science field. You are going to deal with the big amount of data and there it should be the consideration. Okay, then here you have unbalanced cluster. Unbalanced cluster, when let's assume that you have a cluster and everything is fine, all are occupied, all are having good amount of data, and all is working in the same way, whatever is your expectation. Okay. So you have this rack 1, rack 2, rack 3, and rack 4, or any n number of racks. Then let's assume that you are having here you can read I was assigned a map task but don't have the block. I guess I need to get it. Means this is assigned, but this is not having the blocks. All blocks are here. You can see this is full of blocks. This is also full of blocks. This is having nothing. This is having nothing. Maybe these are new racks and new data nodes which are added to scale the cluster. Okay. So in that case, they are not having the records, any data, any blocks, any replica or anything. In that condition, the cluster is unbalanced in the initial phase, but that will be balanced. Okay. Then it is having Hadoop. Hadoop prefers local processing if possible. Now servers, this will be taking for my produce task whatever is running with the HDFS, more network bandwidth, slower job times and all, because it is unbalanced, right? So next what will happen? This will be trying to redistribute the data between the clusters, and the cluster will be balanced in the next phase. Here cluster balancing, all will be moving because these are having the too much data is available here and available here. In the next phase, data will be redistributed. Okay, I am having more load. This is saying, okay, I am having also more load, and these are the new are having completely free. There is no space occupation. Completely, it is bucket. In that case, this will move the data from one node to another node. This will try to balance, and balancer utility, if used, run in the backgrounds and does not interfere with map reducer or HDFS. This is not interfering anything, and default rear limit 1 MB and all. Okay. Then like that, it is going to maintain the data node, maintaining the name node, maintaining the cluster, even in case if any new racks and new data nodes are getting added, then how it will balance? Because whenever new one is getting added, then nothing is there. So it has to take care. Okay, I have to balance the volume and all. So let's balance. So this will be doing the data movement, and it will be balanced completely. And all the things will be maintained by the HDFS-site.xml. Here you can see DFS balance and bandwidth per se. This parameter is available in HDFS-site.xml. This can be useful for this one. Um, Network traffic balance. Okay, here you can see the amount of network traffic balance can use is very low with the default setting of 1 MB. The settings can be changed with this parameter, which is available in this file. So like this, the total cluster is getting maintained, and how it is working, how it is balancing and all. And same concept you will be seeing anywhere if you are going to create a cluster for your job deployment. Because anywhere if you are going to create the cluster, let's say either it's Azure or you are going to create the cluster in AWS, and all concept will be same in backend internally. So they have adopted the same model, how data is working in the distributed mode with the multi-node clusters. Single node, multi-node. Single node is for testing purpose only, where our driver and means how your master and slave driver and worker node all will be running in the same machine. So that is for testing purpose. But for our actual work, project work and all, we always go for the multi-node cluster, at least more than one node, you can say. All good or any question? Any question?
Yeah, no, actually, little bit confusing, but we'll go through that PDF like document,
Mhm.
and yeah,
But I would
it's
like
clear.
to know what is confusing.
Like many things was going on. That's why it's totally on theoretical also. So that's why like need to go again that document. We'll go today, and if I stuck anywhere, we'll ask him tomorrow.
Yeah, sure. Of course, this can be because these things are completely new concept, right? So again, if you see multiple things are getting repeated, whatever I said, multiple times, the same blocks, the same data node, same kind of replication is coming. But once you understand the flow, then it's easy. I believe so. You will be also saying the same after a few days.
Yeah,
Yeah. Once we are new, then we think that it's complex. But once you will be familiar, then nothing is complex. It will be fine. Okay. Then in the same directory, This is the HDFS command, okay, which you can do. And then this was HDFS practical scenario. This you can take it later once your command and all is done. This is the use case for your exercise. Again, I will be back and I will take Linux command. So, okay, I will share this as well. Maybe I have not shared. So these are some basic Linux command, Unix or Linux. Okay, if you are not familiar with this, then you can just, this is not much, some basic and important commands I have noted here. Okay, and again in this sheet, you can see some commands are here. You can go and you can just type it and run it and see. If you are good with this, then these are something which you will be having the requirement to run on daily basis. If something new is coming, then again you can explore anytime. Like ls listing the directory, cd changing the directory, pwd printing the path where we are currently, mkdir making new directory. If you want to delete the file, if you want to delete the directory, if you want to remove any of the folder forcefully deleting the file and renaming the file, copying the file, moving the file, or viewing the content, editing the file, getting only head and tail. Head and tail in the sense you have a file with 100 lines, 1000 lines. You want to see, okay, this file belongs to which data. Let's do, means let's read first 2 lines, first 10 lines like that. So head hyphen and then 10 uh, file name. Then it will be giving that there's those many lines, 10 lines, whatever number you are providing, that number will be displayed in your output. Then file permission means you have a file. There can be something like anyone can read, anyone can write, anyone can execute. So either you want to restrict the permission that people can read, but they should not write, they should not have access for execution, or no one should read the file. You wanted to remove all the access permission, or you want that, okay, you can read, you can write, but you can't execute. So you can have the permission set up as well. Here I'm seeing 777. 777 means read, write, and execution. 755 means this is one group. There will be group. You have, see here I have mentioned what is 777. So if you are saying chmod 777 means file have all the permission, read also, write also, execute also. But what is this? 7 means 4 read, 2 write, 1 execute. 4 plus 2 plus 1 equal to 7. Means you have give read permission also, write permission also, execute permission also. First number is for the owner. You have 777, 3 times 7. One first is for owner, second is for the group, for which group you are, and the third is for the others. Other people what can do like that. Maybe for the owner you want 7, for the others and a group you want 0, 0. You don't want to give any permission like that. Then owner read, write, execute. All the access have 777 means 4 plus 2 plus 1. Group also 4 plus 2 plus 1 and others also 4 plus 2 plus 1. But let's assume that for owner you want all 7, but for group you want only read and write. For others you want to read only. Then what you will do? Here you will write 7. For this you will write 6. For this you will write 4. 4 means read. Then they will be having permission of, this will be having read permission only. This will be having read write and this will be having read write and execute. So you will be giving chmod 7, then 6, then 4. Then 7 means first group is having, owner is having all the access. Group is having 4 plus 2 6 means read and write only. And for the last one you will be mentioning 4. That means others are having only read access. Like that you can maintain the access and all. So you can do the exercise. Again, this is for the process management. If you want to know the list of current process, then top viewing the running process, terminating a process, network commands related. If you want to check like if config, then ping google.com and all. Disk management you want to check how much is disk space is utilized, how much is available, and estimate file space usage and all. Then system information, what is about the system, who is the username, about memory usage and all. If you want to search something, let's say you have a file and you are not sure where this word will be, so you can do grep search for the text in a file. You can say grep pattern and then file name, so it will be searching that whatever element you have given, whatever content, if based upon that this will be searching from that file. So these are some basic commands you can run around and you can see that. Okay, so I will go to this. This is all done. It is running fine. Then I will go to the terminal. Let me take a new terminal from here and I will show you. Let's say I'm doing L. I will create a file, new file. I am doing VI using VI editor. I will create one and I'm saying learning.txt. Then I can write anything. Let's say we are learning data engineering with Hadoop. Okay, then let me save it. Now this file is available. If you see learning.txt, what is the permission? Permission is read write for the first group. Second group read write. Third group is only having read R permission. Okay. If you see some files are having D in the beginning. D means what? D means directory. So those are directory. They are starting with the D and the files are starting with hyphen. Okay. So this is the difference. Now okay. Then I want to change the permission. Okay. What I can do first before changing the permission, I want to move that into another directory. I will create a new directory mkdir and Hadoop. Let's say I'm saying Hadoop directory. It's done. Now if I will do ll, I can see Hadoop directory. This is Hadoop, right? This is starting with D. So this is directory. Now I want to move this file from this path to Hadoop path. If I do pwd print current path is home and Cloudera. So I can take, let's say CP. CP means copy, MB means move. If I want to maintain copy, one copy here also and one copy there also, then I can CP. Or if I want to move no copy, then I can use directly MB. Okay. So let's say CP and then this path home Cloudera. Then my file name was learning.txt and I want to move it to home Cloudera and Hadoop, this path. Now I will check the Hadoop folder. See, this file has been moved and this file is maintained here as well because I did copy. This is maintaining one copy here also and one copy there also. If I could have done MV, then it is as this will okay. As we have already this file available, so it is asking, do you want to overwrite? Yes. Now let's see. LL that file got disappear, right? Now this is not available here. And if we will look at into the Hadoop, then it is available. So CP means it will be maintaining one copy in the source also, destination also, and MV means this will move. It will not maintain the file at the source. That is the difference. Now, if you see the access rights, it is having three group. For first group, it has RW, read and write permission. For second group, also RW. For third group, it is having R. What I will do? I will do ch mode, and then I will make first 1 to 7 read, write, and execute means 4 plus 2 plus 1. Then for second one, I will keep read and write only means 4 plus 2 6. And for third one, I will make read only means 4. Then okay, first I need to enter into the Hadoop. I want to be in the Hadoop directory, so I will do cd Hadoop, change directory. Now you can see Hadoop. Now I am inside Hadoop directory. Okay, I will change the path here. Sorry, not path, permission. Chmod 7, 6, and 4 means first is having all permissions, second is having only read and write, third is having only read and learning.txt. Now check the permission. What do you see? Here is see the difference, here see the difference. First this is green means it is having read, write and execute. RWX. Second one is having only read and write, third one is having only read. You can check the permission. Now I will change again. I will make this also as 6. Okay. Then see again, this is not coming as green because I removed the execute access. Okay. Or I want everyone to have all the access. So I can see, okay, make 7, 7, 7. Everyone should have all the access. Anyways, in real time, we never provide all the access to everyone because anyone will be good to modify the file, delete the file, read and all. So it's not recommended. Always restrict the read write operations for others. So now everyone is having all the access. Read write execute, read write execute, read write execute. So like that you can maintain the access for the file or for the directory, anything. Let's say I am going back, one step back, and now I am doing LL for Hadoop. This is Hadoop. This is having permission of read, write, execute. And for third group, it is having read and execute, but not write. Write operation is having blank dash, right? What I can do, chmod and Hadoop. Then LL. See, now Hadoop, see the differences between here Hadoop was and here Hadoop is. Now Hadoop is having all the access, read, write, execute, read, write, execute, read, write, execute. So either you can do for file level or you can do for directory level, no issue. Okay, again I will change the this one permission. I will make it 7, 6, 4. Or let's say 5. 5 means read and execute, but no write. They can read, they can execute, but they can't write or modify the file. Now if I say, okay, now it is okay. Uh, this second one can't execute, third one can't write. Fine then. This is the Linux command I will share. You can go through that. And anyways, just ask. Any one of you is having experience with Linux Unix command?
Only little bit,
I don't
barely.
have.
Okay, no issue. You can go through that. Then let's start with our HDFS. Okay. Here, if you go to this drive and let me open this. HDFS commands. Here you can see first we have, if you want, I was discussing about HDFS-site.xml, right? Let's say you want to do something, then you can try find, and once you find, then you can go to the path and you can check about that. Then we have Hadoop FS and HDFS DFS. Both will be working, and you can use any of the keyword for the syntax to run the HDFS command and all. Okay, like Hadoop FS -mkdir or HDFS DFS and same command. They are having some internal differences, but syntax wise you will be getting the same. Let's go to this and first let me see if Hadoop is running fine. Hadoop FS-ls. Okay, it is running fine. Then what was the command here? It was sudo find /-name. And what is the name? Name is hdfs-site.xml. So if you have any file which you do not know the location where it is, but you know the file name, you can try to find out. It will be giving you the location wherever this file is. So see, with these many paths, that file with that name is available. Okay, with yarn, with HBase, with HDFS, with uh, CC deploy, and for your Hadoop configuration, Cloudera, multiples are there. So you can check with anyone. Everyone is having some different things. But for example, you can take any. So let's say I am taking this. Okay, let's take this one only. See what is there. This Hadoop conf Cloudera one. This is for Hive. Okay, this is for Hadoop conf sudo impala. Again Hadoop. Let me take this one. Copy and vi. Anyways, for opening the seeing the content, you can do cat. Vi is the editor. And here you can see these things, right? DFS block size. This is the default block size. Then DataNode host name. This is false as of now. Permission. You must mode. Then this is then NameNode enabled false. Then read. Then domain socket. Then different things you can see here, right? Multiple things will be there. DataNode HDFS blocks metadata enabled true. Then you come to the same again, and you can take some other files as well. Let's say cat, and I will take this one first one. User leave Hadoop map reduce. Copy. Paste. Okay, so here you can see this data node directory and times. And here, if you go up, let me take in VI mode. Okay, this is, you can see here heartbeat interval, right? We were discussing about after each 3 seconds, heartbeat will be shared from data node to name node. to make sure that they are communicating. And for block report, where it is maintaining the metadata, that will be for 10th heartbeat, means 30 seconds. Then in different files, you have different setups you can check out with the different path. Okay, so you can check up like that and you can go through it. Anyways, I do not have right permission, so I need to do Q.
Namika, one question over here.
Yes.
So here through terminal, we can see, we can list out all the files and we can create. So if we want to see all the folders in the files on GUI, so where we can see them on HDFS?
Of course you can.
Yeah, we can, but from where?
One minute. Okay. So you are talking about GUI, right? So here once when you are coming to this browser itself, whenever we are starting our servers, right? You can see here you have Cloudera, you have few Hadoop, HBase, Impala. You can go through this and you can explore HDFS, NameNode detail, open. This is your Impala, this is Spark. Anyways, all the things maybe it is not available here, but in the real time it will be available with you. So this is
So
about
we have created a folder Hadoop, right?
no, we have not
Onto the
created. This is
Cloudera. So can
no,
we
no,
see that folder?
we have not in the GUI. Everything will not be available with the GUI and all. So this is your HDFS. Okay. Here in the HDFS, if you come, you can see here your status instance. 1 minute. Okay, so here this will be giving you all the details about, let's say this is having data node, name node, secondary name node, host and all, everything is there. So this is giving you all the details. Now, this is your name node web UI. And then if you go here, quick links, you can try exploring. Okay, so these things you will be getting according to this one. And then you go to your data nodes. Then this is again, it will be giving you the capacity, whatever capacity you have, and all the details here. And then, but whatever you are expecting to see everything in the GUI, it will not be, because this is not defined in the same way. Let me go to this one
Can you click
overview.
on the Cloudera?
This one.
Yes.
This will be going to the home. This one. This is the Cloudera home. Okay. And then you can go, you can expand with the services, whatever you are looking for. This is about Cloudera. So all those details will not be available with the UI, and this is completely Linux based. You have to go and you can check from there. These will be giving you all the details and all. You are looking for everything to explore from UI.
Yeah, I have seen folder structure in home Cloudera. But I know.
No, where you seen?
Uh, can you switch back to the first tab?
Cloudera?
Cloudera, click start.
Yes.
Not here. First tab of the browser.
Uh, here is the browse.
We are on the second tab now, and I am this browser window.
This one.
Can you click on the first tab? No, from the top, under the title.
This
Come out
is
from this. Above the
this
address
one.
bar, there are two tabs, right?
This one.
Yeah, this one.
This is the Cloudera service where we are getting.
Yeah.
Means we are tracking all the things.
Yeah, can you click on home? Home tab.
This one.
Yes.
Okay. This is the main service where all the services are installed. This will give you all the details. I understand what you are looking for, that, but this will not work according to that.
Yesterday
You are,
yeah,
you are looking
I
for everything
explored.
to be managed by the UI and all, right? This is not like that. Yeah, go ahead. Whatever you were talking about.
Day before yesterday, I created folder
Huh?
in under the home Cloudera,
Huh?
and then that folder I could see that in the folder structure. So I
Okay.
need to explore where
That you can, of
I
course,
can.
because see, the main thing is, we I have never explored because I never got that, and I believe that no one is preferring that because these command lines and all are most preferable, most familiar and all. Okay, if you are
Yes.
good with that, and you will be good with this. This is going to help you a lot. And if you are good to access all that locations, you are good to do with the UI, then that's good. But need to check where it is. So if you come here, this is click start Cloudera and go here and see this is the CDH and this is your mount path. This is the data node log files. And in the anyways, you can explore this, okay? And you can check from where you can access that file. But I feel that you can learn a Linux command. You should learn
Yeah,
that.
I can learn. I just
And
wanted to
you
see.
should
Yeah.
always prefer that only because that is going to help you in multiple things.
Yes.
Okay, but when you explore, just let me know as well. Where
Okay.
you are good to check all the details and files.
Okay.
Okay, fine then. We can go to
Yeah, just a minute. Uh, Under the main menu, can you see input
here it is.
above?
Here only.
Above in the browser. No, above.
Huh?
File, machine, view, input, window, devices, and help. Right?
I'm not getting.
In the browser.
This is browser. Okay, this one.
Above it. Yeah.
File mesh.
Under
Huh?
input, there is a places, right? Places. Not
Input
here.
I have.
No. Just, yeah. Come out from here. You can see places under the input,
Yes.
right? Yeah.
This
Click
is
on
not
this.
under the input. This is below.
Yeah. Here. Home
Then
folder. Home
okay.
folder.
You have explored a lot.
Yeah. Here you can see
Okay.
Hadoop. You have created, right?
Okay. So
Hadoop folder is there.
okay, whatever I created. Let me
Yes.
check because
Or
you know
script folder, script
I never
folder.
go
Yes.
through this.
Yeah.
I
This
always
is.
prefer Linux command. Okay. Then this is learning. Let me click out here. Learning to display its content. Yes, display. Okay. That's good. But again, I will say never ever prefer
No,
this.
no.
Okay.
I have created through command line
Because
only,
you
but
will
I
not you
just
will not learn commands.
no. I have created the folder and file through command only, but I just wanted to check that whether it is created, where it is
That's
showing.
good. That's good.
Yeah.
That's great. Yeah. And this is okay. You can explore all the things. Okay. But the main thing is you have to learn that command. So do
Yeah.
not prefer this.
Yes. Yes.
Okay. If you will prefer this, then you know what will happen. Let's say you have to create the file. You will go and you will create from here, file and new. This is, we all know how to create the files, how to create the folders and all, because we are working in MS Word and all, right?
Yes.
So we
Yes.
know all these things. But you will not learn the commands and all, which is required. So never ever prefer this. Just for the verification and validation, it's okay. Okay. Then, uh, okay, so I was assuming that you are talking about UI where you can have all the structures and details like we see for like any web app and all, right? Okay, so that is not actually here, as you see in the home folders and all, you are good to see the structure. And here this is the main thing which you should go through that. Let's say for the admin part, about the CPU, about the disk, about the networking, all the details they can monitor and they can take the decision or whatever they want to detect or monitoring and all the things about each of the services they can. Like let's say here it is having red critical. So this is not running fine, or maybe that is having some issue. If you see the all health issue, then health issue, this is having some uh, criticality. So these things will be there, but again, they are going to monitor the admin team and all about the clusters. But this is not as per developer. This is not our task, our job. Okay, and then let's go to this. So like this, you can go with the Linux command. So try to practice that. That command is going to help you for the Hadoop as well. So let's say I am going with this command Hadoop fs hyphen mkdir uh, learning one learning one. I am creating a directory. That directory will not be local directory. This will be Hadoop directory because I am giving Hadoop FS. If I am giving only mkdir, then it will be local directory like we already created for Hadoop. And same command you can run with HDFS DFS as well, not only with Hadoop FS. That will also work in the same way. So let me create one more HDFS and DFS mkdir learning 2. Then we will validate both. Then in this document, whichever you are seeing here, I have mentioned almost all useful commands. You have to just uh, take this command and run in your system. You can replace the path according to yours, like home, Cloudera. This is the my folder name and file name. For example, you can replace this with your input and output path. Remaining command will be same. So this is done. Now I will say LL. I think I gave wrong. LL is not a command supported in its Hadoop site. Only ls will be. Okay, so if I did ls, then two directories had been created. One I created with Hadoop FS, one I created with HDFS DFS. So any you can take in your syntax, whatever Hadoop you are trying about. Okay. Then let's take this copy. I created one learning.txt in Hadoop folder. I wanted to copy that from local to Hadoop, local path to Hadoop path. Then I can say, if you see here the first command, copy from local. Okay, again we have one alternate get and put command for copy and uh, move. But let's start with this one only, copy from local. So give Hadoop DFS, then copy. This is camel case. Copy from local and then your local path. Local path is home, Cloudera, Hadoop, learning.txt, and you have I want to copy it to learning.1. And you know, for the Hadoop side, you have path user Cloudera. This is home Cloudera and Hadoop path means user Cloudera. So here, let me validate one thing. Here you set for the place, right? This is home folder, desktop, document, music. Does this have for Hadoop path? This is for local path only. Cloudera manager and all. Workspace, training, bin confess RC, and connect to server. Okay, this is for server connection. That is not what I am looking for. Okay, then give
That path
learning.
we can execute pwd command and then we can get the.
No, that I know. This is user Cloudera learning. Anyways, if you will give direct also, that will also work without the path, because you are already in the root path, right? So here path is not required actually. This is copied. So let's say I gave the path. If I will not give the path, I am taking 2 and I will remove this. Then also it will work. Okay, now we can verify. Let's say Hadoop FSLS learning 1 and ing learning 1 and learning 2. Both we can see. In both the directories, files should have copied. So like this, you can copy the file. Then you can you also we can move the file. You understand the copying and moving, right? Copying means it is maintaining one copy in your target also and one copy in source. And if you are moving, then it will not maintain in the source. It will just cut and paste from the source to target. Then let's do for 2. Both folders should have a copy. Okay, this is having copy. You can see by default permission is read only for users and group. For others and group, and for the owner, it is having read and write both. Anyways, you can change that permission as per your requirement. Now coming to this file. If you want to copy multiple files, then again you can use similar files. All files are direct means you can copy all the files or some selected files or a directory. You can copy anything. Then move from local. Move from local means you want cut paste, not copy paste. That also you can do. And copy to local and move to local. Both commands are. So this one you did copy from local. You made a copy. Move from local means you want to move means cut and paste. That also you can do. Copy to local you can do and move to local. When I had created this document, that time move to local was not implemented. But now I can check whether this is implemented or not. So my HDFS path Means I want to move from Hadoop path to local path. So move to local, and my user Cloudera. User Cloudera learning one, then star. I want to move everything, and where I want to move, I want to move in home and Cloudera path. Oh, not implemented yet. Still the status is same. Okay, but copy to local it will work. Okay, so you can do copy from local, you can do move from local, you can do copy to local, you can do move to local. Then cp command if you want to make a copy, mv command if you want to do the move, and you have put and get. Put and get is alternative for copy to local, sorry, copy from local and copy to local. You want to copy from your local to Hadoop. Either you use copy from local or you use put simply. When you want to copy from your Hadoop to local, Hadoop path to local path, then either you use this command or you use get simply. So we can try this once. Here I was using move to local. I can do get command.
Is for local and put is for FDFS.
Right. Put and get. So put means you want to put means local to Hadoop. Get means you want to get means Hadoop to local. So if we verify, if we do LL means local, I get this file locally. It copied, right? And if I want to put, put means my local to that one. So I will copy this file itself. This is the JSON file, right? I will just try with this. I had copied from local. Now I will replace this command with put and learning.txt. Let me replace this with this file name. Copy and paste. Let's run. So we can use either copy from local copy to local, or we can simply use put and get. Both will be working fine in the same way. So this should have, let me do ls learning 2. This is one node cluster only. This takes few seconds, but in real time that will be actually very fast. You will not be having this much latency. That will be working perfectly. Now you can see this has been copied. So either you use your previous command or you are using your put and get. Both will be working fine. Then you come here. You can see next is get merge. Get merge write multiple file contents into the single file in the local file system. So you can apply this command. Then you have make directory as we already seen. Making directory mkdir. Then touch J is for creating empty files. If you want to create empty file, rm remove a file. If you want to delete any of the file, let's say Hadoop FS -rm and your file name. Here you can run it. then -rm for file and rmdir for your directory. And then learning2 and file name is learning.txt. Learning.txt. Let's run it. Then this file should disappear. What it says? It is deleted. It is saying trace policy default name node trace configuration deletion interval this much and minutes moved to this trace folder. It has been moved to this trace. Okay, and there it will be maintained for a time period as per the configuration, and then finally it will be deleted from the trace as well. So now this is deleted. Let's do learning 2, and there should be only one file, this express, and not the learning one. So like that, either you can delete the directory, complete directory, or only file, anything is okay. Okay, only express deployment is there, that file is not there. And if you want to remove this entire one, you can do rmdir. Sometimes we can have directory, then subdirectories, then inside subdirectories we can have file. If you want to force delete or you want to soft delete, this will be guiding you, and even sometimes it will be asking either you want yes or no. Like this is saying this is not empty, so either I should empty this folder first, then I should do rmdir, or I can try with force delete as well, rm-r. Okay, this moved, right? So RMDIR, if you are applying, then it will be asking you that it is having subdirectories or it is having files, it is not empty. So either you should first empty, then you can delete, or if you want force delete, that whatever it inside, I don't care, just delete that. In that case, you can go for -rm hyphen r, it will be force deleting. Okay. Then like that you can practice, and then you have ls, then you have tail, you have head. Head and tail, just I will write once, and then you can go for the this file.gz, and head, tail, word count, line count, characters count, about the disk usage, whatever you were looking for. So here I have mentioned around 40 commands. Okay, you can check that, and then remaining can be okay. For one line also there is a page. Okay, so like this you can go, and let me try this command first. Cat command. So as of now here we have this learning.txt, right? So it is okay. Let me do this one, cat and enterprise. Let me see how many lines are there. So many lines are there. I want to cat. If you come here, hyphen tail. Mhm. What is this? What I am doing wrong? Yeah, 5. So -5, it is giving only first 5 line. If I do tell, sorry, this was tell only. If I do head, then it will be giving first 5 lines. So like that we can do the analysis. Then here is two different command I will show you quickly. Then you can do on your own. You can run all. Here you have fsck command is there. Sudo Hadoop fsck and then your folder. Then I already deleted the folder, right? So I will create one folder, mkdir. So here using this, you can check the health system. Again, this is the admin command, but just I have mentioned here for your information. So sudo hadoop fsck, you can give your HDFS folder name, and then later you have one DFS command. So two commands you can check out. Sudo hadoop. What is the command? Sudo hadoop fsck folder name. fsck and learning too. It is saying use of this script to execute HDFS command is deprecated. Okay, anyway, this will be giving the output. And then we have one more command. This one, HDFS, DFS admin -report. Uh, HDFS, DFS admin -report. Okay, here I had given, I should have given full path. Because of not giving the full path, it is saying invalid path name. Okay, you can see it is giving all the details like this is the, sorry, this is from here. So configuration capacity, present capacity, DFS remaining, then DFS used and under replicated, block with corrupt replica, any corrupt replica, then there is 0, no corruption, missing block, missing blocks with replication factor 1, by default here it is, and access denied for user cloud era. Anyways, that is another thing. And here I will be giving the full path one more time. User cloud era will see this. So like this, you can check the health report and all. And again, I will repeat, this is for admin, not for the developer point. This is just for your information. Okay, so here you can see all the details, total size, the total directories. This is giving the detail about this particular directory, whatever we created. Then total files 0, there is no file because I deleted and then I recreated. Then what all details about this directory, you will be getting everything here. Okay, number of racks, you can see this one also. Rack is 1, data node is also 1. This is a free cluster, so this is one node cluster only. So all the details you can see. Like this, you go with this document and you should have access to this document. Uh, see the exercises, however it is going on, and then we'll see the next. Okay. Tomorrow we will start with Hive. If you are good with HDFS. Fine.
Yeah, okay.
Okay then. Let's wrap up this session and meet tomorrow. Have a good day. Bye.
Yeah, Happy New Year.
Happy New Year.
Yeah, bye.